Jai Hind everyone, myself Sandeep Yadav, currently working as Associate Professor in the Department of Computer Science. Today I am going to deliver a lecture on Transaction Processing, Unit 4th in DBMS. So most of us are aware of transactions. Transaction is basically a collection of operation to perform a unit of work. So daily we see a lot of transactions are happening. Now we will discuss what are the main outlines of our presentation. First, what is transaction? Then we will be discussing what are the various properties of transactions. These are basically known as acid property. Third is transaction state diagram, and fourth is the schedules in transactions that are used in transactions. Schedule can be a serial schedule, or it can be a concurrent schedule or non-serial schedule. So first we will be discussing what is transaction. So as I already told you, transaction is a sequence of operation performed as a single unit of work. Transaction is logical unit of work. Basically it contains SQL statements. For example, let us consider a transaction where we transfer $50 from account A to account B. This is how we are going to write the transaction. See, this is a transaction where we are transferring Rs50 from A to B. So in order to transfer Rs50 from account A to account B, we need two operations. One is read operation, another is write operation. So read operation, what it perform is, it transfer the value of data item from the disk to the buffer. And write operation it does is that it transfer the value, updated value from the buffer back to the disk. So these two operations are very critical operations that are needed in transaction processing. So in this transaction we will be first reading a value of A. Now the value will be read from the buffer. So first the value is to be brought to the buffer from the disk. That is performed by read operation. Thereafter we are transferring 50 rupees. So now A is equal to A minus 50. Thereafter, after updating the value of A, now the value need to be reflected back to the disk. For that we will be using write operation. So write operation updates the new value in the disk from buffer to the disk. Now again next instruction is read B. This data item is B. Now B equal to B plus 50. That is, we are transferring 50 rupees from A to B. Thereafter, now the value has been updated. Now we will be performing write B. Write B will update the value of B in the disk. The value is still in the buffer. From the buffer, the value will be fetched to the disk. This is how the transaction processing will occur in this transaction. See, here the instructions are being written in sequence. It is a single schedule. Now we will be discussing what are the various acid property of a transaction. Now a transaction has four main properties. Those are known as acid properties of transaction. First property is atomicity. Either transaction execute 100% or transaction execute 0%. Means either it is 0 or 1. Intermediate state is not allowed, right? Either half of the transaction is successful or half of the transaction is not successful. That is not allowed. Either it is completely successful or none of its operation are. Second property is consistency. Consistency means that database must remain in consistent state after the transaction as it was before the transaction. Consistent state means the state must be accurate, right? then the total amount before the transition and the total amount after the transition must be remain same as was in case of previous example. Next is isolation property. Isolation property means intermediate transition must be hidden from another concurrent transitions that are executed parallelly. Means the transition must be unaware of the other transitions that are running parallelly to it. That is how we are going to maintain the isolation property. Next is durability. Once the transition completed successfully, the changes must be made permanent in the database. Now, we will be first discussing atomicity. Now, this property states that the transition must be treated as a single indivisible unit, that is, it must be treated as a atomic unit, that is, all the operation of transitions are executed or none are. Either transition execute 0% or it execute 100%, not 60 or 50%. Complete success should be there. Complete success is considered when it is 100% and 0% it is a case of failure. A transition may end in failure also, or it may end as a success. So, there are two ways in which a transition can end. It is either a success or it is a case of failure. Now, let us consider an example of transition. Read A equal to A minus 50, write A, read B equal to B plus 50, write B. Now, we will be transferring rupees 50 from account A we will be transferring 50 rupees from account A to account B. So, if 50 rupees are deducted from this account, right, and are not, then it must be added to this account B. If from here the amount is being deducted, if from here the account is being deducted but not added here, then it will fail. And if the amount is deducted from here and being deposited here, then it will be successful. Next property is consistency property. It states that the database must remain in consistent state, the accurate state or the correct state after the transition as it was before the transition. In our example, total A and B must remain same as it was before the transition. See, suppose earlier the value of A was 1000 rupees and B was 2000 rupees. So, the total is 3000. Before the transition, the total was 3000. Now, after the transition, what is the value of A? The value of A is 950 and the value of B is 2050. Now, we will compute the sum. Now, the sum is 3000. So, the total amount before the transition and the total amount after the transition remains same. So, we can say that the property of consistency has been maintained because the database is in correct state after the transition, because the total sum remain unchanged. Isolation. Changes occurring in a particular transition will not be visible to other transitions until it has been committed. Intermediate results are hidden from the transitions that are running parallelly to it. In our example, our transition start from first step, that its results should not be accessed by another transition until the transition is being complete. This property is more important in case of concurrent execution, whereby several transitions are executing simultaneously, whereas in case of serial transition it is automatically maintained, we don't have to make any extra effort. But in case of parallel transitions, we have to use concurrency control techniques to maintain the property of serializability. Next is durability. Durability means that after the transition successfully complete, the changes that it has made, it must be made permanent in the database, even though there are system failure. A failure in system may occur due to variety of reason. It may be a glitch in the software, it may be problem in hardware, it may be transition related, it may be related to DBMS, or it may be related to operating itself. So there are variety of reasons. A disk crash may also occur, system crash may also occur. So variety of reason may be possible, but the changes must remain persistent, that is, it must remain permanent in the disk. Once our transition completed up to the last step, as it was in the example, in our example last step was step number 6. Its result must be stored permanently. It should not be removed even if the system fails. That is, initial value, suppose A is 500 and B is also 500, then after that the value of A is, after the transition the value is 450 and B is 550. So these value must be reflected in the disk. Then we will be saying that the property of durability has been maintained. Durability, actually the word itself means long lasting. So the changes which are made in the disk must be long lasting, that is, it must be permanent in nature. Next, we will be studying various state of transitions, that is, various phases in the transition processing. Let us illustrate it with help of a suitable diagram. Now, first we will be seeing the active state. So as soon as the transition start, we say that transition is in active state. That is, as soon as we start with the first line, we will say the transition has entered the active state. Now next state is partially committed state. When the transition executes final operations, we say our transition is partially committed. See, it has finally completed its execution, then we will say that transition is partially committed. Here it starts in active state. This state is partially committed. Next state is committed state. When the transition successfully complete, then we say the transition is in committed state. That is, the changes are reflected in the disk. The changes are of permanent nature. Then we say the transition is committed. No abort or rollback can be done in such a case, because the changes are being made permanently in the disk. So that we will say at that point the transition has committed. But there are also various other possibilities also. It is all that everything is going fine and the result is ending in success. But there are cases of failure also, for which the transition may enter in the failed state. Now failed state is a state after the transition normally does not proceed, then we say the transition is in failed state. A failed state may be a result of a variety of factors. They may be due to an internal error in our transition, they may be due to disk crash, they may be due to the deadlock condition or the transition has been rolled back by the DBMS itself. So, a variety of reason may be possible in case of failed state. Now, after the failed state, next state is abort state. In abort state, whatever the changes has been done by the transition that has doomed, that has failed, then those changes must be undone, right? Those changes must be undone, that is done by the abort state. Here we roll back whatever we has done, whatever the sequence of operations has been accomplished, we need to roll back them, we need to undo them in case of failed state, that is we have to abort them. Now, abort state will come after the failed state. First the transition will if the transition fail, then we will be proceeding to the abort state. For example, in this case the transition fails here, so amount 50 has been removed from this account, but it does not add up to this account. So, we need to undo this value. Suppose this value is 500, now this become 450 and the transition fail, then we need to undo this value, that is we will be using abort, we will be using undo command to roll back this value. So, now we will be aborting this. So, this value will be aborted as case of failure. Now, a transition may also fail. There are two ways a transition may fail. Either it comes from directly active state to the failed state, or it may come from the partially committed state also to the failed state. That is, suppose the transition has completed its last line, but the value has not been made permanently, changed in the permanently in the disk. There may be variety of reason there. A disk failure may be there, a power failure may be there, a variety of reason is there that we are not being able to proceed from here to here. So, as a result of failure from here to here, we may land in a failed state also. So, a failed state we can come from active state also, and we can come from the partially committed also. In partially committed, all the lines are executed, but these changes that are done in the transitions are unfortunately not reflected in the disk, resulting in the failure. So, as a result, our transition will land in the failed state, and after the failed state, our next state will be abort state. Either the transition will commit or the transition will abort. Both of these states will result in end. Either it is completed successfully or it end as a failure. Now, first state, as I have already mentioned, it is initial state. The transition state in this state while it is executing. Second state is partially committed. When a transition executes the final operation or instruction, we say that it is in partially committed state. Third is failed state. Whenever the transition no longer normally execute, we say the transition is in failed state. So, once a transition cannot complete, any change made by it must be undone. Committed state, the transition enter in this state after the successful completion of the transition, that is after coming the commit state. Now, we cannot abort or roll back from this committed state. Next state is abort state. The state after the transition has been rolled back is known as abort state, and in this state we will roll back all the changes that we have done previously. So, in a nutshell we can say that there are 5 main states in the state diagram of the transition: active state, partially committed state, failed state, committed state and abort state. Most of the time the transition is in active state. Some of the time is being devoted to the partially committed state or failed state. So, significant amount of time must be devoted to the active state. Now, next topic that we are going to discuss in transition processing is schedule. So, what is a schedule? Schedule is a grouping of the transition into one and executing them in predefined manner. That is, we have chronologically ordered the instruction set and executing them in well defined manner. That is, it is the chronological order in which the instructions are being executed in our system. A schedule is required in database because when some transitions execute in parallel, they may affect the result of another transition. Consider example of, there are various example of schedule that we use in daily life. For example, timetable in the class, it is also time of schedule. It reflect which lecture will be held now, which lecture will be held later on, and so on. And schedule word we already use in our day to day life. What is your schedule of today? Means what task you are going to perform at what time. That is also type of schedule. But in case of transition, schedule means the order in which the instructions are going to be executed. Which instruction will be executed now, which instructions will be executed later on. So that all the things are being shown in schedule. Here, if one transition is updated the value, while other transition is accessing it, then the order of these transitions will change the result of another transitions. So, a schedule is needed or required to execute the transactions. Now, following is the example of schedule. This example consists of two schedule. This example consists of two transition T1 and T2. Transition T1 read the value of A, then update the value of A, then transfer that amount to B. In another transition T2, it reduce the value by 10% of A and then add it into the B. Now this schedule, in this schedule, first we will be reading the value of A, thereafter the value is being updated, then write operation is being done, that is the values are being reflected in the disk. Then this amount will be transferred to account B. Now here transferring is being taking place. Before transferring, we need to read the value of B. What is the initial value of B? That is present in the buffer that we need to read. Thereafter, after performing this, we will be performing write operation, and after that we will commit the transaction, that is the value that has been changed will be reflected in the disk. Now, after the completion of this transition, another transition starts, that is T2. Now, it will be reading a value that is being written here. So, it will be reading a value, suppose the value is 950 here, then it will be reading 950. Thereafter, it will compute the value, that is 95. Then, in the next step, A equal to A minus temp, then the value of A equal to 950 minus 95, that is 855. Now, this value will be added to the value of B. Suppose the value of B is this one, then B will be, new value of B will be previous value of B plus the temp value, that is 95. So, 2095 will be the value of B. Thereafter, we will be committing the transition. Such a schedule where there are two transitions that are executing, but here transition T1 completes its execution first. After the completion of execution of transition T1, then transition T2 commits, then transition T2 starts. So, it commits, after the commission of this, T2 starts. After the commit operation of T1, transition T2 starts. This type of schedule are known as serial schedule. So this is a serial schedule. These are the various value we can compute, but such schedule are known as serial schedule. A serial schedule is a one in which first transition completes. After the completion of first transition, the second transition will complete. Such a transition is known as serial schedule. Now let us consider this example. Here there are two transitions T1 and T2. This is again an example of a serial schedule. Transition T1 is reading the value of A, then doing some modifications and then writing some value in B. So first instruction is read A, then temp equal to A into 0.1, A equal to A minus temp, whatever the value is being committed. So initially the value of A is 1000, then the temporary value of A is this one, that compute as 100. Now the value of A will become 900, then another instruction start, that is B. Now the initial value of B is thousands. Now the updated value of B is 1000 plus the value of temp. The value of temp is 100. So the value of B becomes 1100. Then this value will be committed. Now the value of A and B will be committed. Now what value this will be reading? The A will be reading a value in transition T2. In transition T2, A will be reading the value that are being written by transition T1. So A is reading this value. A is reading a value that is being written by T1. So A will be reading 900. Thereafter, the value of A is being updated. So the value is 900 minus 50. Then the updated value is this one. 850 is the updated value now. And now B will be reading a value 1100. This value. B is reading a value that is being written by T1. The value being written by T1 is 1100. Now the value of B becomes B equal to 1100 plus 50. So next the value of A becomes 1150. This is again the updated value of B. Now suppose after that another transition T3 wants to execute the schedule, wants to execute itself and want to read the value of A and B, then it will be reading the value 850 and the value of B is 150. Now so we will be saying that a serial schedule is a schedule in which no transition start until the previous transition has ended. So if first a transition will complete its execution, then second transition will start. Such a schedule is known as serial schedule. A serial schedule, formally we can define, it is a schedule in which one transition is executed completely before starting another transition. Transactions are executed one after another, that is one completes then other will start. This type of schedule we have discussed is known as serial schedule. Thank you everyone.